Okay, so what we're going to do is we're going to go back and review this anatomical relationship between the hypothalamus and the anterior pituitary, and then look at the anterior pituitary hormones. You probably want to have your handout that you're turning in today to double check yourself about how some of these anterior pituitary hormones, where they go and what they target and what they do. So what we summarized just a moment ago is that the hypothalamus, because the nerve cells which control tropically the anterior pituitary, they don't extend all the way into the anterior pituitary, which is different than when we saw the posterior pituitary. So what happens is the hypothalamus releases tropic hormones, which are shown here by the little purple dots. Okay, so you could say that could be TRH in this pathway, thyrotropin releasing hormone, or it could be gonadotropin releasing hormone. Pick any of the 7 that we just kind of mentioned a moment ago. In order for them to target the anterior pituitary, they have to be secreted into the specialized portal vein, which directly shunts blood from the hypothalamus down to the anterior pituitary. I think we addressed that last time, didn't we? This is a direct shunt. It allows these hormones, these tropic hormones, to be released in lower concentrations. They go straight through as a direct drop-off, if you will, over to the anterior pituitary. So each of these tropic hormones target different cells in the anterior pituitary. So the diversity of the anterior pituitary really isn't illustrated. It's showing like there's maybe one little cell, okay, that's an endocrine cell, but there's various types. There's 6 different types of cells in the anterior pituitary, which would each release a specific hormone, prolactin, growth hormone, FSH, LH, or whatever. Okay? So each of those types of cells would be located in the anterior pituitary. And so what we're going to look at is how these anterior pituitary hormones, which hypothalamic tropic hormone stimulates their release or maybe inhibits it, and then what they go on to do, what they go on to target. What questions do you have about the relationship between the hypothalamus and the anterior pituitary before we look at some of these pathways? Comfortable? Uncomfortable? Got some winces? Questions? So the connection is what? Hypothalamus controls the anterior pituitary how? Tropically, by releasing a variety of tropic hormones. Referring to 6.5 in your textbook, this illustrates some of the hormones, or I guess all of the hormones from the hypothalamus, which regulate the anterior pituitary. The hypothalamic cells and their hormones are highlighted in the purple. The anterior pituitary cells are highlighted in the beigey orange area. And then the body, or described as being the systemic circuit, the body tissues are summarized in the lower red-hand boxes. And then you'll notice that some of these anterior pituitary hormones are actually tropic, and so that's why you see another arrow and some additional effects. In these pathways, the plus indicates that a tropic hormone is stimulatory for the release of an anterior pituitary hormone, and then a minus indicates that it's inhibitory through the release of an anterior pituitary hormone. So what we're going to do is we're going to look at each of the anterior pituitary hormones and say, well, which releasing or inhibiting hormone triggers the release of these particular hormones. So what you should find is that there's going to be some familiar, I can't say that, it'll look familiar. You'll see the RH, the R stands for releasing, or you might say IH, which stands for inhibiting. Okay, so releasing. And so take it away from our lab a couple weeks, the hypothalamus releases more than just thyrotropin releasing hormone. It produces additional releasing hormones, which would target specific cells in the anterior pituitary. What we're going to study, for example, prolactin releasing hormone acts on the anterior pituitary to release what? Prolactin. Growth hormone releasing hormone tells anterior pituitary to release growth hormone. Corticotropin releasing hormone tells the anterior pituitary to release. Not cortisol itself. Cortisol actually comes to the adrenal Vortex. We're going to call it adrenocorticotropic hormone, or you could just say corticotropin. Corticotropin releasing hormone causes the release of corticotropin. Thyrotropin releasing hormone causes the release of thyrotropin. You could say thyrotropin, or we said what? The thyroid stimulating hormone. Gonadotropin releasing hormone causes the release of things called gonadotropins. So they'll tell you what they release. Prolactin inhibiting hormone inhibits the release of prolactin. So these are all coming from the hypothalamus. And they target the anterior pituitary to release or not release their respective hormones. And as I mentioned, some of the anterior pituitary hormones are tropic. So thyroid stimulating hormone targets another gland called the thyroid. ACTH, adrenocorticotropic hormone, is tropic. It targets the adrenal gland. The growth hormone is also tropic to your liver, which can release another hormone. And your gonadotropins, I'll clarify in a minute, target other glands called the gonads for their hormone release. So make a reference to figure 6.5 so you can hopefully get a visual of this relationship between the hypothalamus and the anterior pituitary. Additionally, if you have the guided notes, when we go through these pathways, it might be useful for you to take what's labeled as page maybe 5, where the anterior pituitary is highlighted. You might want to just, maybe if you can, just take it out so you can see the tropic hormone from the hypothalamus going in the portal and targeting. It might help to just keep that visual relationship next to you. So what we're going to do is, just like we did on Tuesday, but now we're turning our attention to the anterior pituitary hormone. The first hormone we're going to study is called prolactin. You can abbreviate this PRL. And remember, we're going to focus on the more gender-specific responses. And so I should have had you guys showed it already, so it's there. But we would say this is prolactin comes from the anterior pituitary, so it is controlled how? Tropically by the hypothalamus, and specifically which hormones? There's 2 hormones. Not oxytocin. If I want to release prolactin, I need to prolactin releasing hormone or prolactin inhibiting hormone. Are the tropic hormones which control the release of prolactin. So it's tropically regulated. What is the relationship between PRH and PIH? They are probably, we could use that word, but what word did we use to talk about 2 hormones? They are antagonistic. But their effects are inverse or opposite. But prolactin releasing hormone is antagonistic to prolactin inhibiting hormone. What is it going to target? What is prolactin going to? Mammary gland and smooth muscles, for example, in the uterus. And the smooth muscle. It targets the mammary glands. Things called lactotropes cells that help make milk. It's important for milk production, but also milk ejection is involved with that somewhat, and uterine contractions as well. So it's part of after a woman has a baby, right? So she's gone full term. Think about how large the uterus had to get, right? Darn large to accommodate the growing baby and placenta, and that uterus has to kind of go back to its pre-pregnancy size. And prolactin will help those muscle contractions and healing and trying to get there. So every time a woman nurses, for example, you've ever had a baby or know someone who has a baby, you nurse and they're like right away, like, oh, start buckling down and cramp pains basically. The hormone is telling those two muscles to contract as part of the healing process. So, you can blame prolactin. Something else very cool about prolactin, not in the human, but in rodents like mice, it's that prolactin surge. It's like actually in a mouse, they'll have a huge prolactin surge, and that's when they start making their nest. And so it's ready to have their little litter. So it's a pretty cool hormone. So because it targets mammary lactotrope smooth muscles, it's important for milk production, milk ejection. We also gave an example of the uterine.
So is this only after? Like, do I have it right now?
Yes, you do.
Okay.
It is not only after, right, pregnancy, and recall, you would also find it in both genders. You would find it, we tend to focus on it during pregnancy or after pregnancy because that's where it's most pronounced. However, for example, in the male, you'll see it released post-copulation, okay? And that's that, they call it the latent period, basically. So it's the period after copulation where there's not copulation without getting into any visuals, right? It's not happening. So prolactin is released, and this allows for bonding and cuddling and love and all this. So it's also involved with just the mental kind of love and happiness and et cetera. Yes?
I looked at it simulates the growth of breast. Is that wrong?
I don't know that it stimulates mammary growth so much. Does it? Okay. I didn't know that it was involved in that pathway. So certainly where I was going, no, not erasing. A lot of your also sex steroid hormones are involved in the maturation of the secondary sex organs such as the mammary tissue. So I didn't remember prolactin being in the pathway, but it's not. So that's okay. So, I mean, what you guys just asked then, is it just these two things that hormones do? Is it going to be just the one thing that I list for a hormone and you're going to say, no? We're going to say, well, what's the more well-known things? But certainly if you're interested in the endocrine system, I highly recommend that you take an endocrinology class when you get to university. You'll love it. All right, so another hormone from the anterior pituitary is called TSH. You should be able to know this pathway, so I want you to check yourself. I want you to fill in your guided notes and write its name, how it's regulated, its target, and its function, and how it's controlled, or how to feedback mechanism. Do you have the guided notes? So the name, the regulator, the target, and its function. TSH stands for thyroid stimulating hormone. Does anybody remember what else we could have called it? No. Thyroid stimulating hormone could also be called what?
Was it thyroxine?
Which one? Did I hear it? Thyrotropin is another word that we could call thyroid stimulating hormone. We can't call it thyroxine because thyroxine comes from where? The thyroid gland. Completely different hormone, completely different source, target, structure, nothing alike. So if we can call it thyrotropin, we now know how it's controlled. Tropically by the hypothalamus, which happens to release, which stands for? Oh, no, not thyroid releasing hormone.
Regulating.
Thyrotropin releasing hormone. Were you on the lab? There's one lab, someone said that. They're like, can you imagine your thyroid actually being released? Like, I release you. Your thyroid gland is gone. Like, no, don't release the thyroid gland. Stay in there, okay? So it's called thyrotropin releasing hormone from the Hypothalamus causes the release of thyrotropin. So it's controlled tropically by the hypothalamus with the release of thyrotropin releasing hormone. So TRH stimulates the release of TSH. That tells us what it does. Its target is the thyroid gland to produce thyroxine. Thyrotropin releasing hormone tells the anterior pituitary to release TSH. It goes into the blood circuit to target the thyroid gland. It causes the release of thyroxine from the thyroid glands. Let's add something here in that. Okay, I'm gonna add something when we get to the thyroid gland. I was confused between the organs, so sorry about that. I'll come back to that. Okay.
So its source is the hypothalamus.
Which it? There's 7 things. No. Where does TSH come from? The anterior pituitary. The source for TSH is from the anterior pituitary. But to release it, we need something from the hypothalamus, which is what? TRH, thyrotropin releasing hormone. So TSH comes exclusively from the anterior pituitary. The next few hormones are have the exact same pathway. The next hormone we're going to study is, we're moving to the next one. This is controlled by negative feedback, and so it's the release of TSH is controlled when our blood levels of thyroxine are out of set point. What's going to determine our set point levels for thyroxine? Not the thyroid. It doesn't control the set point, it just responds. It's just an effector. So where's our set point for thyroxine probably? Hypothalamus. Yes. And so when we get into the thyroid gland, and I try to mention it, if I didn't mention it in all labs, I tried to mention it. Thyroxine, I could call T3. I could loosely say T4, or I could say thyroid hormone. Thyroid hormone is easier to say than T3.
What are you going to call it?
Probably thyroxine. And it can be confusing. That's why I try to illustrate in the beginning of the semester how different things have different names depending on who's talking about it. So if you talk to a biochemist, they're going to call it triiodothyronine. But you would rather say, well, let's call that T3. Like, well, someone else will say, I'd rather call that thyroxine. That's easier for me. Very good.
Talk about it.
Yes, and so repetition is going to be key to differentiating. Was there something else asked, Riley? Did you say?
No. I just also just
Yeah, so probably thyroxine's what I go with. Another hormone from the anterior pituitary we'll call adrenocorticotropic hormone, or ACTH, which sounds like a heck of a lot, and it is a big word to introduce. But if you learn the name, you understand that it's a hormone that is tropic to the adrenal cortex. Okay? So that tells us already the target. What is the ACTH target? Adrenal cortex. How we're going to regulate it? Tropically by the hypothalamus. Which hormone can cause the release of ACTH, adrenocorticotropin hormone? And we'll just call it corticotropin releasing hormone. Corticotropin releasing hormone. CRH from the hypothalamus tropically stimulates the anterior pituitary to release what? Adrenocorticotropin hormone, ACTH. We know that it targets the adrenal cortex, okay, exclusively just the outside portion. What does ACTH tell the adrenal cortex to do?
Stimulate secretion of glucocorticoids.
Stimulate the secretion of, and I'm going to pull off that prefix gluco, you can say corticosteroids, such as glucose. That's just one example of 3 types. So ACTH tells the adrenal cortex to release corticosteroids. Again, maybe a new word, but if you work through it backwards, steroids, which come from the cortex, Glucocorticoids are an example, but they're not the only ones released by the adrenal cortex. Corticotropin, just corticotropin releasing hormone. Comes from where? Corticotropin releasing hormone comes from the hypothalamus. It targets the anterior pituitary. We're in the anterior pituitary. Adrenal corticotropin releasing hormone from the hypothalamus targets the anterior pituitary to release ACTH, adrenal corticotropin hormone. It goes into the general circuit and is tropic to the adrenal cortex. So that tells us we're going to talk about the adrenal cortex and some more hormones. But before we get into any details, we're just going to say, well, they're called what? Corticosteroids. So that means they go out and do something. You said there's 3 types? There are. But we will address those hopefully today. So I want to focus on the anterior pituitary before we get out of the head. It's controlled by negative feedback as well, and in relationship to existing levels of corticosteroids. And so those are hormones, so I really could have just said what? Those are steroids, I could have just said steroids are types of hormones, so I could have said tropically. They're controlled tropically and in relationship to existing levels of the products of the adrenal cortex. If they're too high, should we keep this pathway going? No? And if it's too low, should we stop the pathway? If it's too low, we want to keep the pathway going, right? So negative feedback. And of course, the nervous system is involved, the hypothalamus. I could have put that really on all of them, how the hypothalamus is involved in this. The pathway will seem similar. We're going into our 4th anterior pituitary hormone. The next hormone is called growth hormone. We can abbreviate that GH. This has another name as well. Just like the other terms, growth hormone is a lot easier to attain, right, without investigating too much. Or I could say it's somatotropin. Somatotropin is the proper name for this hormone. That tells me this is tropic to the body, just the whole body. Okay. So what do you think it targets then? The whole body. And so the liver, your muscles, your bones, and your fat. How is this controlled? How is this anterior pituitary hormone controlled for release? Tropically by the hypothalamus, specifically which hormones? RH, growth hormone releasing hormone, causes the release of growth hormone. Antagonistically, there's a second hormone called GH. GHIH, growth hormone, inhibitory hormone. So its release is very precise with these two antagonistic hormones. We mentioned as well that it does target the bulk of the liver, including your bones, your muscle, and the fat. So the primary targets. It promotes what? Growth, metabolism. Your bones might become stronger. Maybe if you're young, they become longer. Your muscles might become what? Stronger, bigger, right? So more proteins added. Fat, bigger and stronger? No, what happens to your fat? There's two types of metabolism, so it gets metabolized, it gets broken down to power all the other growth promoting anabolic reactions. And so growth hormone you could summarize as being protein anabolic and fat catabolic. So it tells the fat to break down to power things like muscle building, protein building, cell division, etc. At the liver, growth hormone is tropic. And what that means is the liver can release a hormone, and the hormone is called IGF. You can just take it at face value. I'm not going to get into the pathway. But I'll tell you the name. It's called insulin-like growth factor. It probably also promotes what? It's insulin-like growth factor, so it promotes
Something like insulin.
well, what does insulin do? It has something to do with metabolism, blood sugar, right? So it tells your cells to take in nutrients. And so it's kind of like that. And then it also has a metabolic effect. It's just another messenger. Growth hormone, just like any of the other hormones you would find throughout one's life. So you would find it in higher expression when you're younger. And as we age, the growth hormone levels actually decline, which solidifies with aging why our muscles get smaller, less protein within them, and our bones get weaker, and etc. Right? So it's still present, but it just declines throughout age. Any questions so far? Hopefully with the repetition, we're getting on example 5. You should start to make a connection from the hypothalamus and the anterior pituitary. The remaining two hormones collectively are called gonadotropins. Did we use that word last time? Gonadotropins. The remaining two hormones from the anterior pituitary are called gonadotropins. Again, with or without the H. There are two types of gonadotropins, and those are our remaining hormones on the list. Our gonadotropins probably target the gonads. Okay. How do you think we're going to control their release? If our gonadotropins come from the anterior pituitary, we're going to control them how? Tropically, from the hypothalamus by gonadotropin releasing hormone. Gonadotropin releasing hormone will initiate the release of two types of gonadotropins. The first gonadotropin that we're going to study is called LH, or luteinizing hormone. This hormone is probably the least descriptive in what it does. Luteinizing hormone. In your midterm, did y'all hit that? Lutein?
I've only been in a week.
Oh, okay. Anybody else on midterm seen that word? Lutein? It's referred to yellow okay, which again means maybe nothing to you at this point. Gets its name, okay, so I'm not going to hold you accountable for this, but I've got to diverge so it makes sense to you, okay? So when a woman ovulates an egg during a reproductive cycle, an egg ruptures the ovary. And the ovary is very analogous, it's not a blister, but it's visually analogous to a blister when it ruptures. Boom. If you've ever had a blister, you know that there's a site of injury. The ovary also has a big open area, so it needs to heal. As it begins to heal, an entire extra set of cells and an entire, really, tissue grows in there. It's called the corpus luteum. Corpus means what? Corpus means what?
Shell.
What?
Shell.
No, corpus means body. Corpus luteum means what? Yellow body. The thing that grows in there is actually yellow at the site of ovulation. It's called a CL, corpus luteum. Ladies, if you've gone to a doctor for reproductive assistance, you may talk about your CL. If you've been pregnant, talk about the maintenance of the CL. The corpus luteum is initiated by the release of luteinizing hormones. So there's a correlation there. So that's where it gets its name from. We actually visually can see a yellow organ as an endocrine gland that's secreting hormones.
Does that happen every time you ovulate?
Mm-hmm.
That seems like a strange way to
It is not strange. The CL actually is an endocrine gland, so then it goes on to make a hormone which maintains pregnancy. And so that CL has to be there to maintain a pregnancy. And if it's not, pregnancy's not going to fly.
So do some people not have it?
It could not form, or it could underform and just not produce enough hormone, and so it would be below set point in the pregnancy. And so it could be kind of a checkpoint, I guess, for the body, like something may be amiss or whatever, and so it's a safety mechanism, if you will, for the baby and the mom.
So what hormone is it in charge of the
Corpus luteum, so this is still a diverge. The corpus luteum produces a hormone called progesterone, which you may have also heard if you take the pill. If you take the pill, you're taking synthetic progesterone, which, if you're taking synthetic progesterone, what does your body think you are? Pregnant. So if you're pregnant, you can't, we're not kangaroos, so can't get pregnant, you're not ovulating. Well, you'll still ovulate, but your body, you may still ovulate, but your body's going to, it's not going to release.
So does the, like the little yellow thing, the GL or whatever?
CL.
CL, so the egg is not fertilized, does that go away?
Correct.
So you don't have like a ton of them in there?
No, it'll go away. It'll go away, it'll recess, and it'll digest, and it'll turn into almost like a scar, and the corpus albicans, it'll be white, it'll be hard, and then it'll go away, and so it'll be, at some point in time, it'll look like maybe a little divot on the ovary. That's really cool. Yeah.
Does when the pregnancy happens in the fallopian tube, is there a malfunction of that hormone?
Probably not a malfunction of the corpus luteum, some type of transit, usually just a physical, mechanical transit of the oocyte down the pathway. So with that divergence, luteinizing hormone might make more sense. Luteinizing has to do with yellow and all that downstream, right, reproductive effects. Okay, so luteinizing hormone was characterized best in the female, but is it present in males? Yes, it is. Okay, it's found in both genders. It used to be a completely different hormone. It used to have a completely different name in males, and females are like, no, it's the same hormone. So we said it's going to be regulated how? Tropically by the hypothalamus with the release of gonadotropin releasing hormone. Causes the release of this gonadotropin called luteinizing hormone. It probably targets our gonads, okay, which are what? Ovaries and testes. Okay. And so what luteinizing hormone has to do with is some maturation of what's called the follicle, which I described as kind of like the blister-like thing, if you will. Prior to ovulation, there is a huge positive feedback surge of LH. So it's the LH surge which initiates ovulation, or rupture of the follicle, release of the oocyte out into the reproductive system. Secondarily, it initiates the production of progesterone, which we just mentioned a moment ago, so supporting that corpus luteum, and our more familiar feminine estrogen. That's in the female. In the male, it promotes the synthesis of the masculinizing hormone called testosterone from the testes. So it's those hormones from the gonads, which are initiated for release by the presence of LH. The second gonadotropin is called FSH, which stands for follicle stimulating hormone. It also gets its name due to female studies. Follicle stimulating hormone was best characterized initially in the female. And it's talking about how it acts on the ovarian follicles. But we now know that, we've known for a while, that it also targets the male. So how are we going to control it? Tropically by the hypothalamus with the release of gonadotropin releasing hormone causes the release of this gonadotropin as well. It also targets the ovaries and testes, the gametes, or excuse me, the gonads, and it promotes the gamete production. So the production of the sperm cells and maturation of the eggs. Both the eggs and the sperm, which is summarized with the word gamete. These pathways are discussed more in the end of the textbook with the reproductive system. We generally do not have time to talk about the reproductive systems we were talking about so much already. So if you're out of curiosity, go back to, I don't remember what chapters they are, but at the end of the book, the reproductive systems there. So you might want to look at some of these pathways and just get a visual in the CL, for example. That actually concludes our anterior pituitary hormones. Took us an hour to talk about. Essentially, but we can take away that they're pretty important for maintaining things from metabolism all the way to the reproductive system. We learned that each of the anterior pituitary hormones are controlled tropically by a specific hormone or hormones to trigger their release or inhibition. On the far left, we talked about prolactin and its primary target, including the mammary glands. We talked about growth hormone and its non-tropic effects on the bone, the skeletal muscle, and our adipose tissue. However, the remaining 4 hormones, we would have technically said are tropic because they each target different what? They target other endocrine glands. So it tells us we've got to talk about the thyroid gland yet. We've got to talk about the adrenal cortex and the ovaries and the testes as well. The thyroid gland is stimulated by thyroid stimulating hormone from the anterior pituitary. The adrenal cortex stimulated by adrenocorticotropin hormone, or ACTH, and the gonads stimulated by the gonadotropins. What questions do you have at this point over the relationship between the hypothalamus and the anterior pituitary? What I want to now do is go and talk about the thyroid glands. We had a nice introduction to it in the lab a couple of weeks ago. The thyroid gland is described as being butterfly-shaped. You look at the image, you kind of see that. And it has 2 lobes, and it's in your neck region. And normally, you probably wouldn't really be able to, if everything's working, you probably shouldn't be able to feel it real bulgy or kind of squishy, if you will. So only if it's swollen, it's probably going to be some kind of thyroid problem, okay, or illness. The thyroid gland produces a hormone which we became familiar with previously, called thyroxine, which we said could also be called what? T3, or we said even T4. I'm okay with that in this class. Or we could even call it just what? Thyroid hormone. Okay. That is not the only hormone that it produces. It also produces another hormone we'll talk about called calcitonin. We'll go there in just a minute. Additionally, the thyroid gland has a whole other set of glands on the back side of it, called the parathyroid gland. So in this tiny area of your body, 3 types of hormones being released from the neck region. The first hormone we're going to study is thyroxine. So I want you to complete. So if we look at thyroxine, we know that we have some alternative names, T3 and T4. Give you some structural cues about it, whether it has 3 or 4. You might know that 3 or 4 is reference. It's in reference to iodine. So T3 has 3, triiodizyrene. T4 has 4, tetraiodizyrene. Okay. So they're structurally similar, but one has one more iodine than the other. We also could have called it generically just a thyroid hormone. It's regulated, we said how? Tropically by the anterior pituitary, by its release of TSH. Thyroid stimulating hormone stimulates the release of thyroxine. What does it target? All over, the whole body, all of our body cells, and most, sure there's some cells are like, no. But, so we'll say this, most of our body cells express thyroxine receptors, and the effect is what? Regulating and enhancing metabolism is what we've been putting our blinders on for the last couple of weeks when we're looking at it. And that's certainly what it does. That's not all that hormone does, though. It also causes cells to become more sensitive to the sympathetic nervous system, or the SNS abbreviated here, the sympathetic nervous system. So you're more sensitive to norepinephrine and really epinephrine. Okay? So when your sympathetic nervous system is activated and you've got thyroxine, your heart rate is going to go which way? Up even more than if there was no thyroxine. Your respiratory rate is going to go up. Digestive system activity would go down, right? So it enhances the sensitivity, or basically expression of your epinephrine receptors.
Why is I feel like everybody right now says I have a thyroid problem, or people are on medicine more than ever. What is it that's happening in this?
I don't know if it's more than ever or just your awareness. I don't know what I don't know if there's been a big change, but problems with the thyroid are not uncommon. They're probably, I don't know the percentage, but they're very common. In any class, I can probably have at least 2 people directly affected with the thyroid problem. There's a lot of reasons. It could be genetic. It could be dietary problems because this hormone is dependent upon iodine intake. Additionally, women, and I don't know for what reason, tend to have underactive thyroid glands with age. And so it's just one of those lovely things us girls get to go through, and probably most likely to go through. And so it's cancer of it is pretty common. Underactivity is it's pretty common, and other things like other diseases could cause a thyroid problem. So it could be genetic too. It could be an autoimmune. Your body could attack it, yeah. And so there are many reasons why someone might have a problem with the thyroid. The most common one is just underactivity with age, for example. And females tend to have that. I haven't looked at any numbers to see if it's shifting one way or not, but I'm gonna guess it's probably just your awareness of it and listening versus when you were 10.
Yeah.
You know? Okay, good question. I want to add, so where it says thyroxine on your guided notes, I want you to add or differentiate that thyroxine is made by the follicular cells of the thyroid gland, the follicular cells. Follicle is kind of a generic word for kind of a fluid-filled area. So thyroxine, T3 and T4 are manufactured in the follicular cells of the thyroid gland. If you were to take a cross-section of the thyroid gland, you would see some fluid-filled spaces called follicles. Okay, they'd be analogous to the visual I tried to give you earlier, like little blisters. They're not blisters, they're fluid-filled follicles. Lining them are cells which make thyroxine. So I'm going to try to draw some follicles. So on the inside would be the follicular fluid, or the lumen would have the follicular fluid. And these cells that I'm trying to draw here are the ones which are responsible for making thyroxine. Okay? And so you would have lots of these microscopically, right? Just cranking out thyroxine continuously. Okay? So it's these follicular cells. Okay? Follicular cells manufacture thyroxine. I want to differentiate this because there's another set of cells in the thyroid gland that make a completely different hormone. There are cells in between your follicular cells called parafollicular cells, and they make the next hormone on the list called calcitonin. So next to calcitonin, put parafollicular cells.
And that's on the back of it?
That is not on the back of it. It's actually in between the follicles. I'll draw them in just a second. Made by the para. The parafollicular cells are in between the follicles. And what do they make? Something called calcitonin. Okay. So the thyroid gland itself makes two types of hormones. The follicular cells make for us calcitonin. The follicular cells make for us thyroxine. The parafollicular cells make for us calcitonin. What does calcitonin have to deal with? Something. Calcium levels in the blood. So how is it regulated? By the thyroid gland. It's not regulated by the anterior pituitary, and it's not intrinsically regulated by the thyroid gland. Humorally regulated in response to what? Calcium. Do you know which levels? Since you're on a roll? Calcitonin tones down calcium, so it must be humorally regulated by too much calcium. Okay? It is humorally regulated by excessive levels of calcium. And it's produced by the
Thyroid gland.
parafollicular cells of the thyroid gland. What do you think calcitonin can target in your body to bring your calcium levels down to set point? Your bones? Tell your bones to do what? Absorb calcium. Very good. Can target your bones. What else could it target? There are three primary targets. Your bones. The blood itself wouldn't be the target. There are no calcitonin receptors in the blood. The blood is just a transporting tissue. It can target the kidneys and the intestines. And what can the intestines do if my blood calcium level is too high? Pretty much right now. Let it go. Let it go. Right. Let it. Right. Just don't try not to absorb as much. Very good. And it may go out as waste. Excrete it. And the kidneys. What could it do? Same thing. Excrete the calcium. So it can target your bones for storage. Kidneys and intestines do not absorb so much, so excrete excessive calcium. To bring your calcium levels, the function is to bring calcium levels down to set point. Calcitonin is antagonistic to the next hormone on our list called what? Parathyroid hormone. Parathyroid hormone is produced by the parathyroid glands, which are located behind on the back side of the thyroid. It is not the thyroid itself, it's another set of glands on the posterior side. So the average person is going to have 4 parathyroid glands, 2 behind each lobe. The parathyroid glands are shown here in these golden little structures. Some people have as many as 8, and some people as few as 2. And they still are able to regulate their blood calcium levels, no problem. So the parathyroid gland, how do you think it is regulated? Oh, parathyroid hormone, how do you think it's regulated? Humorally, in response to low levels of blood calcium. It probably also happens to target bones, kidneys, and intestines. To do what? Bones to release stored calcium. Kidneys and intestines to absorb calcium and put it into the blood. To bring calcium levels up to set point. Very good.
So why can it vary between like 2 and 8 the amount or 2?
Just not everybody's built the same is the reason really. Question was why there's sometimes 2, why there's sometimes 8. Genetics.
Would there be like an adverse effect by having less or more?
There is not an adverse, or that I know of, an adverse effect not having enough or not having 4 parathyroid glands. If there's 2, the workload is still shared. If there's 4, the workload is still shared. And if there's 8, workload is still shared evenly. And still works. These 2 hormones are antagonistic one another to maintain our blood calcium in set point. Okay, ranges. We've got about 2 minutes. I want to use that to transition and turn our attention to the structure of the adrenal cortex, because it looks simple, but it's not. It's complex. There's 3 layers, 3 types of hormones coming out of there. So I want to introduce you into the structure of it, and then you guys will read about it over the weekend. So when we come back on Tuesday, we're going to talk about the adrenal cortex and its 3 layers. So real quick, let's label these layers. The cortex is the outer portion. Of the 3 layers, the outermost portion, they're all called zones. Zona. They're going to have the preceding zona. The outermost layer of the cortex is called the zona glomerulosa. So this kind of thin area right here. These cells make up the area called the zona glomerulosa. The layer below that is called the zona fasciculata. And then the third area is called the zona reticularis. So in order from outward in, zona glomerulosa, zona fasciculata, zona reticularis. Each of our major categories of corticosteroids are produced by each of these layers of the adrenal cortex. So over the weekend, I want you to review the adrenal cortex and the different corticosteroids coming from there. Claire, did you have a question? All right, why don't you guys put your hand in your handouts at the end of the table. We will see you on Tuesday. Go ahead and come prepared for chapter 12 lecture, but we'll wrap up chapter 6. And we'll see you in lab or in class on Tuesday.